Hello everyone, Assalamu alaikum. Today we'll be showing you the implementation part of experiment 3B. We'll be going over three different circuits. The first one is differentiator, the second one will be difference amplifier, and the third one will be voltage to current converter. We'll start by showing you how to measure the resistances, and then we'll show you how to measure the bias voltages and fix them. To measure the resistances, today I'll be doing it in a slightly different manner. What I have done is I have placed the resistors on my breadboard, and I will use the multimeter to measure them individually. The first one is the 1K. As you can see, the value can be seen to be 0.98 kilo ohm, so that's approximately very close to 1 kilo ohm. So let's see the next one. The second one is 2 kilo ohms. The third one is 5 kilo ohms. The fourth one we have 10 kilo ohms, and finally is 101 kilo ohms. As you can see over here, this is your 1 kilo ohm over here. This is your 2 kilo ohms. This is your 5 kilo ohms, and you have 10, and finally the 100. Now that we are done with this, next we'll measure the voltages. Now to fix the bias voltages, first we'll switch on the breadboard, and then we'll take the two probes of the multimeter, and one place the black one at the ground point and the red one at plus 15, which is the yellow knob over here, and then go to the multimeter and press on DC voltage. As you can see, the voltage being shown is only 1.28 volts, so we'll change the knob, the plus 15 over here, increase it, to fix it as close to as possible to 15 volts. So that's 15.15 volts. And for the next part, what we'll do is we will measure the negative 15 voltage, that is the blue knob over here, along with the ground connection. It's negative 14.7. I'll try to slightly increase it. That's close by. I think that's okay for today's experiment, but I'll still increase a little more. Yes, so it's close to 15. Yes. Next, what I'll do is I will show you the connections that I prefer to make today, because it will make the experiment more convenient. What I'll do is I will connect cables, color-coded cables, to the plus 15, minus 15, and the ground. So as you know, this point over here is your plus 5 volts. The one over here is your plus 15 volts. So I'll fix the yellow cable to plus 15 volts. This yellow cable actually corresponds to your knob over here. As such, this is based on this knobs I'm making the color coding. And for the next part, for the third line, which is the -15, I will connect a blue cable. Okay, there you go. And finally, for the ground part, which is the fourth line over here, I'll fix a black cable. So once I'm done with this, I will do two more things. That is, I will fix the input and the output for ease. As you can see, this is your function generator over here, and the cable from here, the cable, this cable actually, this cable goes from here, and I'll fix it. I'll keep it to where I'll fix the op amp, and I'll put it at the input side. The black cable will go to your ground, and the red one here will be for your input. For the next part, which is the output, I'll go to the oscilloscope. I will take the blue cable from here. I'll take the blue cable and fix my blue cable at I'll leave the red one over somewhere here for now, and take the ground part of the cable and fix it to the ground. So this way, what we have for this experiment is we have yellow at the plus 15 volts, the blue as the -15. This black wire is the ground cable, and this part will be your output, which will go to the oscilloscope port 2. And for the input part, we have this cable over here, which will be connected to the input of the op amp. Now I'll place the op amp in a position over here, and as you can see, for the op amp, the legs are fixed at specific points with no issues. Okay, and you can slightly press it to ensure that the connection is proper. Next, we'll be showing you the circuit that we'll be implementing for the first part. The first circuit that we'll be implementing is your differentiator circuit. It consists of one capacitor, 1500 microfarad picofarad capacitor with only one resistance, that is a 10 kilo ohm resistance. The connection will go from 2 to 6 with a resistor which will also have a capacitor, and the pin 3 will be connected to the ground. So let's see the connection for this one. If you come to the resistor, the op amp over here, first what I'll do is I'll connect the plus 15, the minus 15, and the ground. For the plus 15, the yellow one will go to pin 7. For the -15, the blue cable will go to pin 4. And for the ground connection, the black cable will go to pin 3. Once I have these connections, next what I'll do is I will connect my resistors. First, I will connect a resistor from 2 to 6. So over here, this is your pin 2 connection, 1, 2 connection, 2, and over here this is your pin 6 connection. And once I place it, I will slightly see if it's connected properly. I'm done with my resistor connection. Next, to pin 2, I will connect the capacitor, the 1500 capacitor. This is your pin 2. I'll connect it over here, and at the other end of the capacitor, I will take the input port and connect it. So as you remember, the connection is vertical over here, sorry, the connection is horizontal over here, so all these horizontal pins are connected. So I'll connect it over side by side, so the input part is complete. For the output part, I'll take the red cable over here on this side and connect it to pin 6. This completes your connection for the op amp, I mean the differentiator circuit. The next task is to switch on your function generator. And the input signal that will be for the differentiator is your triangular shape with a 50% symmetry. So we'll press on the ramp and we'll check the symmetry. It's 100%. We'll change it to 50% and press on this percentage, so that will give you a 50% symmetry. Next we'll check the amplitude, which will be 1 volts peak to peak. 1 volt, this is your peak to peak, and your frequency should be 1 kilohertz. Yes. Once you press on the output, we'll go and see the oscilloscope. As you can see, we have a signal, but it's let's say quite distorted for now. So to see it more clearly, we'll press on auto set. And we have the input as a triangular shape and the differentiated output as a square shape. So I'm placing them on top of each other. As you can see that the output is actually fluctuating. This is due to the ripples that is coming from the charging and discharging of the capacitor. To smoothen the ripples and to make it more stable, we can use the Acquire function in the oscilloscope. And go to 128 points for smoothing it, and if we enlarge it by pressing scale, you can see that the ripples. So these ripples are actually showing you, these ripples over here are showing you the charging and the discharging of the capacitor. Also note down the values of frequency for both the input and the output. This concludes the first experiment for 3B. For the second part of the implementation, we'll be doing the difference amplifier. This is the circuit for the difference amplifier. It consists of 4 resistances, where 2 are 1K and 2 are 2Ks. The first 1K will go to pin 2 and we'll have a 2K from 2 to pin 6. And at pin 3 we'll have 1 kilo ohm and a 2 kilo ohm, and the output will be taken from pin 6. Also note that in the input side we'll have 2 inputs. One will be a triangular function, the other will be a sync function. And if you remember, the sync function will have a voltage peak to peak of 3.44 volts with a frequency of 1 kilohertz. For implementation of the difference amplifier, we'll connect the -15 to 4 and the +15 to 7, and we'll have a 2 kilo ohm resistor from pin 2 to pin 6. We'll also have another 1 kilo ohm resistor which will go from pin 2 and the output of pin 2 will be connected to a sync function whose cable is connected to the function generator. I'm using a green wire to show the input of the sync function. This completes one half of the circuit. For the other half, we'll have another 2 kilo ohm resistor from pin 3. But this resistor will go to the ground. So I'll connect it on top. And I'll take a black cable which is connected to the ground, and I'll connect it beside the pin 3. Sorry, resistor. As you can see, the legs are not touching each other. If the legs are touching each other, there may be an issue. So for the final connection, we'll have a 1 kilo ohm resistor to pin 3. And the input of the pin 3 will be the triangular shape, which is the red cable over here. This completes the implementation of difference amplifier. Next, we'll go to the function generator and look at the input voltages. So for the sync function, which is this cable over here, this is fixed. It will have a voltage of peak to peak of 3.44 and a frequency of 1 kilohertz. For the second part, we'll have a ramp function which will have a symmetry of 50%, amplitude of 1 volt peak to peak, and frequency of 1 kilohertz. After this, we'll switch on the function generator. Once you go to the oscilloscope, you can see the output shapes and press on auto set. And the input is a triangular function. It also has another sync function as the input, and the output we are seeing the difference amplifier output. First, what I'll do is I'll overlap them. As you can see from here, from this bottom scale, for the input part, each box actually shows you half a volts. I will change this and show 1 volts by changing this knob. Also go to the second one and change this, which currently shows 2 volts. I'll also change this to 1 volt for ease of understanding. Once we have this, as you can see, the input half so the input of the triangular, half of this peak is half a voltage, and this peak is half a voltage. Whereas for the output, we can see that we can change the shape slowly to put it on the grid scale. Also bring it down slightly. Exactly, yeah. So over here you can see that this is exactly 1 volts, whereas this part is half a volt. So the difference shows an amplification of 2 times. And previously, this square shape was a flat. It had a flat top. The on voltage was this part. It had a flat shape, but after the implementation of the circuit, this flat shape is being subtracted and being replaced by the input shape with an amplification of 2 times. This concludes the implementation part of the second difference amplifier, but before that, we can press on measure and we can see the peak to peak values, the frequencies, and the mean. which is also the DC value. For the third part of the experiment, we'll be going over voltage to current converter. The objective of the voltage to current converter is to ensure that regardless of changing the load resistance, we will have the same current. To do this, we need to note down the change in the peak to peak voltage of the input and the outputs. So in the circuit, we will have 4 resistors, and we'll have one resistor that will be variable resistor. So we'll have a 5 kilo ohm resistor which will be connected from ground to pin 2, and another 5 kilo ohm resistor which will be connected from pin 2 to pin 6. We will have another 10 kilo ohm resistor which will be connected to the input and pin 3, another one 10 kilo ohm resistor which will be connected from 3 to pin 6. Finally, we'll be connecting a variable resistor of 1 kilo ohm and then 2 kilo ohm to pin 3 and the other end to the ground. In the circuit, first we will have a 5 kilo ohm resistor from ground to pin 2. This is the ground point over here, so I'll connect it, and I will take the 5 kilo ohm and connect it to pin 2. You'll see that it's connected. Okay, so once the pin 2 is connected, I will take another 5 kilo ohm resistor and connect it from pin 2 to pin 6. I will also connect the negative 15 volts to pin 4 and the positive 15 volts to pin 7. Next, I'll be connecting a 10 kilo ohm resistor from the input to pin 3. So as you can see, this is the input, the red one, and I'll bring it closer and take a 10 kilo ohm resistor, connect it from the input to pin 3. As you can see, none of the resistors are touching, and they're also slightly connected properly at the bottom since they're fixed. Yes, and for the final resistor, we'll be connecting it from pin 3 to pin 6, another 10 kilo ohm resistor. This is the pin 3. To pin 6. And the final resistor, which will be changed from 1 kilo to 2 kilo, this 1 kilo will be connected to the pin 3 and the other end of the resistor will be connected to the ground. So I'll take a 1 kilo ohm and connect it to pin 3. And take another ground cable, a black one, and connect it from the ground to the other end of pin 3. So this concludes the circuit implementation. Since this is a small wire, I'll change it for a larger wire. I'm using another larger cable to connect the ground part. So this completes the circuit implementation, as you can see. None of the resistors are touching each other. They're all separated. Next we'll move on to the function generator. One of the inputs, the input will be a sine function. So in the function generator we'll change the input to a sine function, and the frequency should be 1 kilohertz, amplitude should be 1 volt peak to peak, and we'll not have an offset. Next we'll switch on the function generator. Output of the oscilloscope. First we have to place the input, which I actually forgot. The input should be placed at pin 3. Once I place the input, I'll go to the oscilloscope and press the auto set. What is important to note in this output is the peak to peak voltages of the input and the output signal. For the input signal, the peak to peak voltage is 1 volts, whereas for the output signal, the peak to peak voltage is 106 millivolts for 1 kilo ohm resistor. Let's see what changes when we change the 1 kilo ohm resistor to a 2 kilo ohm resistor. We will remove this and replace it with a 2 kilo ohm resistor. Once we replace this, we'll go to the oscilloscope. We can see that the peak to peak voltage of the output function changes from 104 volts to 204 millivolts. 100 millivolts, 104 millivolts to 204 millivolts. Let's see why this change happens and what we understand from it. To understand the changes, we need to understand the objective of the voltage to current converter. The objective of voltage to current converter is that regardless of changing the load resistance, my current should stay the same. To see that this is exactly what is happening, we can plug in the values of voltage and the resistance to find the current in the ohm equation. So for 1 kilo ohm, if we plug in the voltage, which is 104 millivolts, with the resistance, we can find that our current is actually 0.104 milliamps. Similarly, if we do the same for 2 kilo ohms with a voltage which has been fluctuating from, let's say, 2.04 to 2.010, and if we're using 2.08 millivolts, we have the exact same current. This shows that even if you're changing our load resistance, our current remains constant. This concludes the implementation part for experiment 3B. Thank you.